All right, good morning, good afternoon, or good evening, depending on where in the world you're joining us from. Welcome to the Hariri Institute for Computing here at Boston University. We're delighted to have our final speaker in our cluster on machine learning for model-rich problems, after which he and the other speakers in this cluster are going to join us on Monday for a panel discussion. So quick word from me, after which I'm going to pass this on to Andrey Fradkin, one of our junior faculty fellows here at the Hariri Institute. And he's going to introduce our speaker, Josh Blumenstock. Josh is going to talk for about 30 or so minutes, after which we try and leave a good 10-15 minutes for Q&A. Quick housekeeping detail, we'd ask that you take any questions and put them into the Q&A feature. We're going to be using those then to focus the discussion in the latter part. Anytime during the talk, feel free to start dropping in questions. A quick word about the Institute, if you're not familiar with us. The Hariri Institute for Computing here at BU is dedicated to initiating research convergence, accelerating integrated initiatives, and particularly with a focus on social impact, where it meets computational and data sciences. The Institute includes a number of centers, as you see here, ranging from specializations in AI to privacy to various partnerships with external groups like the Red Hat and the City of Boston, for example. We have a whole host of things that people in those centers and initiatives, plus our 250 plus research affiliates do, ranging everywhere from misinformation to cybersecurity to conservation and more. The speakers you've seen on this series began with Cecilia Clemente, who was talking in the context of physics. We had Miguel Besa come and speak about material science. Jacob Bortnick spoke to us about atmospheric and oceanic sciences. And today, we're very pleased to have Josh Blumenstock talk to us from the perspective of the School of Information and in global action. So today's host is Andrey Fradkin. Right, Andrey is an assistant professor of marketing in our Question School of Business. He's an economist who studies digitization and search and matching markets. He's written papers on topics such as design of Airbnb's search and match algorithm, reputation systems, online job search, and 401 contribution choices by workers. Before joining BU, he was a postdoc at MIT. And he's served as review on a variety of the top journals and conferences in this area. He's provided expert input about the digital economy at the President's Council on Science and Technology and the Federal Trade Commission. And he worked as a data scientist at Airbnb while completing a Ph.D. at Stanford. So Andrey, it's all yours.
Thanks for that introduction, Eric. We're very excited to have Joshua Blumenstock present to us. Joshua is an associate professor at Berkeley School of Information, the director of the Data Intensive Development Lab, and faculty co-director of the Center for Effective Global Action. The reason why I invited him to give a talk to us is I think he is at the forefront of combining machine learning and economics, and especially using machine learning in kind of new ways and creative ways to help the developing world, and to also surface new questions that come with deploying machine learning systems for social change. He's won a bunch of very prestigious awards and is published in some of the best journals in the world. And I think you could look at a CV if you want to be impressed. So with that, why don't you take it away, Joshua?
Great, thanks, Andrey. Let me just share my screen. You guys are all seeing this, right? Okay. So thanks again for the introduction, Andrey, and for the invitation to present in this series. So as Andrey noted, my work really straddles computer science and economics and focuses specifically on the applications of machine learning to issues of global poverty and development. And since this is a fairly interdisciplinary audience, I thought I would talk about some ongoing work that's really as much policy work as academic work that my research team, and you can see them down here, have been doing in response to help low and middle income countries respond to COVID-19. So Emily, Suzanne, Guanghua are all current or former students, and Dean and Chris are faculty at Northwestern. So to get everyone on the same page and provide a little bit of context, I think it's important to highlight the crisis facing low and middle income countries. I mean, it's very much in the news right now. I pulled this article from about a year ago. And I think the point here is that while COVID-19 has caused pain and suffering everywhere, including in wealthy nations like the US, what's different about low and middle income countries is that in addition to the public health crisis, when you implement economic restrictions and lockdown orders that are really designed to stop the spread of the virus, that takes away many households' primary source of income. And so when you have millions, hundreds of millions of people that are living below or at subsistence levels, when you take away income, that immediately translates into hunger and food insecurity. And this is highlighted by this New York Times article, over 250 million people facing acute hunger. And so globally, what this means is that while for the last few decades, we've actually made quite a bit of progress as a planet in reducing global poverty, for the first time in 20 years, there's now been a actually sharp and sudden increase in global poverty. The most recent estimates I found were from the World Bank, which suggested that on the order of 100 million new poor have sort of made the transition from above the extreme poverty line to below it. And so if these global statistics are a little bit too abstract, I can make this a bit more concrete by showing you some data from Togo. And so I'm going to talk a lot about the country of Togo, a small nation in West Africa, where we've been doing a lot of work recently. And so in June of last year, we conducted a phone survey of about 15,000 people. And it was a 20-minute survey instrument. We asked a lot of questions, but among the many questions we asked, I'm just showing you one, where we asked, in the past week, on how many days did you or someone in your household have to reduce the number of meals eaten in a day? And you can take two things away from this histogram. One is roughly 1 in 5 people in Togo are skipping meals every single day of the week. And then if you take the cumulative sum of all of these bars, except for the first one, this is telling us that over half of the people in Togo are skipping meals at least 1 day a week. And when you see households skipping meals, that's a sign that things are really going wrong. And this can have really devastating and long-lasting effects that have been documented in the economics literature. And so I think that's the specter, that's the real issue that we're confronting. I think, to their credit, governments and humanitarian organizations are not just sitting around idly. They're trying to respond. You see, according to, again, to a report from the World Bank, 1,400 new targeted social assistance programs have been launched just in response to COVID. And I think, unfortunately, these are relatively small programs. I mean, some of them are very large, including the CARES Act in the United States, but almost all of them are what we refer to as targeted assistance programs. And what that means is it's not a universal, there's not universal eligibility. There's some form of targeting that determines whether or not you or your household receives support. For instance, with the CARES Act in the United States, the targeting is based on income as declared in past filings with the IRS. And so this is really the heart of what I'm going to talk about today, like the scientific question, is this what I'll call the challenge of targeting, which is really about how do you identify those people within a population who have the greatest need. And this is a challenge everywhere, right? Like the CARES Act has gotten a lot of criticism for how it's been targeted from all different corners of society. But in wealthy nations, it's just a fundamentally different problem than it is in low and middle income countries. Because what you see in low and middle income countries is just an absence of any sort of recent reliable data on how much specific individuals or specific families have a need for support. And this table highlights just how long it's been since there was a complete census in a handful of countries. And of course, in the middle of a pandemic, when you're trying to minimize face-to-face contact, it's totally impractical to imagine going out and collecting the data that you would use for this sort of targeting, right? So relative to low and middle income countries, the US is very much an outlier because the IRS updates its tax registry every year. But in a country like Togo, they haven't done a nationwide census since 2011. And even in that census, they didn't collect information on income or wealth. So the takeaway, and what I'm going to really talk about, is how machine learning can, in combination with non-traditional data, and by that I'm going to talk about satellite data and phone data from mobile phone networks, how that can create options for solving this targeting challenge. Okay. This is just an outline. What I'll do is I'll spend a couple minutes talking about Togo, then I'll spend about maybe 10 minutes talking about some of the science behind it, and then I'll come back to Togo and talk about how we're using these scientific advances to actually work on the COVID problem in Togo. And then I'll close by talking about some of the broader implications and considerations, not just technical, but also social and ethical involved in this line of work. Okay, so the motivating example I'm going to use to fix ideas for this talk is the Novisi program in Togo. And so Novisi is Togo's flagship anti-poverty program. To date, there's been about 1 million beneficiaries, which is about 10% of the total population of Togo. It's a really innovative platform in a lot of respects. It's 100% digital. So you register using your mobile phone, and then you're paid via mobile money onto your mobile phone. And since March of last year, my research team has been helping the government design and expand Novisi, particularly with a focus on expanding Novisi to rural areas. So I'll show you just like a minute of a video that the government is using to promote and promote awareness of this program. It's in French, so it doesn't really matter if you understand it. I don't understand it that well, but I'll just give you a sense for how this program is being advertised. I think one of the key things they're emphasizing is that this is a digital program where you don't have to have any any face-to-face contact in order to receive benefits from the government. This is just telling you the level of benefits, which work out to be about $15 a month for women and $13 a month for men. And it's paid every 2 weeks, again, directly to people's mobile phones using these mobile money platforms. And I'll maybe stop it after this, but you can sort of see what they really don't want is people exchanging currency face to face. They're like, okay, instead, thumbs up, use the mobile phone to conduct a lot of basic economic transactions. Okay. And so our goal in working with the government has been to improve the targeting of Novisi in order to ensure that the poorest people in Togo are the ones who receive the payments from the government. Because again, there wasn't enough money to provide support to everyone, and the government really wanted to prioritize support to the people with the greatest need. And so there was a 2-tiered mandate from the government, and I'll talk about each of these in turn. One was to concentrate assistance in the poorest villages within the country of Togo. And the second was within those villages to prioritize the poorest individuals and families for support. Okay. So on this first point, again, this may seem like a trivial exercise to people unfamiliar with the situation in low and middle income countries. But again, the first thing that the government wanted to do was concentrate resources in the poorest villages. Why this is non-trivial is because the government of Togo did not, and until recently, has not had any data set that provides information on the distribution of, basically any data set that tells them which are the poorest and wealthiest villages. So what I'm showing you on the right here is a map of Togo. You'll see lots of maps that look like this, showing all of the cantons, where a canton is roughly the equivalent of a county or a couple of villages. And in gray, you can see, so there was the most recent national survey in Togo was conducted in 2018. And they, it wasn't a census. They didn't survey everyone. They surveyed a subset of the households in Togo. And what I'm showing you is which households were surveyed and which ones weren't. Sorry, which cantons contained 0 or more households that were surveyed. Those were the green cantons. And then the gray ones indicate cantons where even in the most recent survey, which was already 3 years ago, which cantons contain no households. And so what you can see is more than half of the country contained no surveyed households. So it's very difficult for the government to then say, okay, what is the poverty rate in this canton or this canton or this canton? And so I want to point out that this, I'm talking about Togo, but this situation is not unique. A couple of recent reports suggest that only half of the poorest countries in the world have completed a census in the last 10 years. And then this very recent World Development Report notes that more than a quarter of the world's children under 5 are not registered at birth. So again, this is a pervasive issue facing the administration of anti-poverty programs, is they just don't know where poverty is, let alone how to remediate it. Okay, so how did we approach this problem? Our approach was to use machine learning to convert high-resolution satellite imagery like this into very granular estimates of the geographic distribution of wealth and poverty that look like this. And there's a lot of details in this arrow right here, and I'm not going to drill down too much, at least not unless you ask me to during the Q&A. I'm happy to expand upon exactly how this is done. Roughly what we're doing is we apply deep learning algorithms to the raw imagery, which work as a way to extract features from the images, things that tell us about the contents of the images. Intuitively, things like, are there paved roads? Are there metal roofs? How much land area does each dwelling have? You know, it's not exactly those sort of features, but it's that sort of information that is contained in the images. Then we use ground truth household survey data to train a supervised machine learning algorithm that then learns what patterns in the images are most predictive of wealth. And then we use that trained model to project out of sample to every single pixel of imagery in the country of Togo what the estimated wealth is. And once we have this high resolution map like this, it's actually quite trivial to then aggregate this to any arbitrary administrative subdivision. And so what I'm showing you here is a map of the locations of the 100 poorest cantons in Togo, where each canton is colored by the predicted average consumption, average daily consumption of households living in that canton. And so again, the policy mandate coming from the Togolese government was to identify the 100 poorest cantons in the country. In order, those are the ones that were going to be first up for receiving aid. And this is showing you how we help them determine which are those 100 cantons. So if there are any questions, I'm happy to answer them in the Q&A, but I guess the protocol for now is to just post them into the chat or Q&A section. I'll also briefly plug that in combination with Guanghua Qi, a graduate student, as well as a former graduate student who now works at Facebook, along with 2 other Facebook data scientists, we've recently released a global version of these microgridded estimates. There's a video capture on the right. I can give you a live demo, or you can actually go to the website yourself if you're interested and explore the estimates. And so our goal here, again, is to just get these estimates out there. We essentially pulled high resolution satellite imagery for all low and middle income countries, trained these machine learning models on household survey data from about 60 different countries, 60 different low and middle income countries, and use these to construct these global micro estimates of wealth and poverty. And yeah, you can go check it out yourself. The data is available both through this interactive website as well as for public download. And other governments outside of Togo are using these exact data to do this, address this geographic targeting question. So for instance, we've supported the government of Nigeria, who is using that data set from the prior slide to target a social assistance program to the poorest urban wards of the country. And so this program has plans to reach about 2 million Nigerians by early 2022. Okay, so back to where I left off. So we talked a little bit, hopefully you get a sense already, roughly at least, of how machine learning and non-traditional data can help solve or help address this regional targeting question. Now I'm going to focus on this question of individual targeting. So the idea here, again, the policy directive was, a little bit of context is, for this particular program that the Togolese government was interested in, they had partnered with this NGO Give Directly, a humanitarian organization that provides cash transfers to people, and had raised about $10 million. And $10 million translates to being able to provide support to something like 140,000 individuals in Togo, if you're doing $15 a month for 5 months. And so 150,000 individuals is a relatively small subset of people, even if you're only focused on the 100 poorest cantons. It's, you know, on the order of 10 to 20% of the population. So the question is, how do you identify that 10 to 20% of the population in those 100 poorest cantons who are going to receive transfers? And so again, I've said this a few times, but it's important that you all internalize this, that this is a difficult problem because Togo did not have the traditional sort of social registry that's used for the targeting of humanitarian aid. And so what the government had done, and they had done this before we had any conversations, and much to their credit, I think, they were being very creative and scrappy to use the data available to them at the time. Their approach was to target informal workers. And this is from April to June of 2020. They launched this Novisi program focused specifically on urban areas. And the rationale being that it was in urban areas where they implemented curfews and stay-at-home orders. And they thought that the people in urban areas would be most impacted by COVID. And then they said, well, look, we don't have a census, we don't have a social registry, we don't really have anything that was, any data set that was collected for this purposes of targeting humanitarian aid. The one thing we do have was a voter database that was updated because there was a recent national election. And so in that voter database, they didn't have information on wealth and poverty, because when you register to vote, you don't tell the government how much income you earn. But at least in Togo, they did provide, people self-declared their occupation. And they also, when you register to vote, you provide your address so that you can be used to assign to you the nearest polling station. So the government used these two pieces of information, home location and self-declared occupation, to determine eligibility for the first phase of Novisi, which provided benefits to about 500,000 people. So urban people, urban workers who worked in informal occupations were the ones who were eligible. Again, using this information captured in a voter database. And so, you know, again, full credit to the government. It's a very clever way to prioritize what ostensibly would be a population with greater need for support. What happened, though, is in the postmortem that we've done with the government was to analyze nationally representative household survey data to study whether or not this particular approach of targeting informal workers in urban areas was effective at getting money to the poorest people, right? Which may not be the same as the people with the greatest need, but it is a relevant question from a policy perspective. And what we find is in urban areas where the program was launched, there's no statistical difference in the average rate of poverty of people who work in formal versus informal occupations. And that's okay, because again, it's the people in informal occupations who were forced to stop working. So maybe you still want to prioritize them, even if pre-COVID they were not any poorer than their formal counterparts. But in rural areas, the situation is very different. In rural areas, and this is largely because the vast majority of people in Togo in rural areas work either in informal occupations or in home subsistence agriculture, that you see that actually the people who are working for wages in formal occupations are on average poorer than the people in informal occupations. So it was pretty clear that for the government of Togo, when they wanted to expand Novisi to rural areas, it didn't really make sense to use this occupation-based targeting. And there's a rich history of related work on this same problem, but just in the interest of time, I'm going to keep going. So the insight that we brought to this partnership, which builds on papers that I and others have been writing for the last 5 or so years, is that mobile phone data, and again, mobile phones are not ubiquitous in Togo, but our estimates suggest that about 90% of households in Togo have at least one mobile phone. That information captured by the mobile phone companies about mobile phone use is highly predictive of socioeconomic status. And the intuition is very simple, which is that different people use their phones differently. And so this is actually results that are in a paper about Afghanistan, but it's illustrative and can give you a sense of the intuition. So there was a large household survey that was done in Afghanistan where people who were involved in this particular study were classified by the World Bank as either being ultra poor, according to this multidimensional poverty index, or not ultra poor. And what I'm showing you here in this histogram is the people who are classified as ultra poor just use their phones a lot less than the people who are not classified as ultra poor. And this is not just true about the amount that people use their phones, but across a whole spectrum of metrics that can be derived from mobile phone metadata, you see stark differences in how very wealthy and very poor people use their phones. And so again, the insight here is going to be that if you can train a machine learning algorithm to estimate socioeconomic status from mobile phone data, then that opens the door to targeting assistance using that, that predicted estimate. And so, the key to this exercise, and again, the key to most machine learning, as you've probably learned over the course of this series, is that having reliable training data is absolutely essential. And so what I'm showing you here is a schematic of the work that was done in Afghanistan. We did something very similar in Togo, I'll talk about in a second, that just shows you what is necessary. So in Afghanistan, we conducted a face-to-face household survey with a few thousand households. In Togo, it was a phone-based survey with about 10,000 households. And with each person that you speak to, you first go through this very extensive informed consent procedure to explain to them the nature of the research and ask for their permission to both conduct a survey and to match the survey data to data that's obtained from the mobile phone operator. Assuming they consent, then you administer this survey where you ask them a bunch of questions about their living standards. I won't go into the details here, but again, if people are curious, I'm happy to discuss it during the Q&A. But from this rich survey about living conditions, we extract sort of this one index that's meant to represent the socioeconomic status of the household. And we can define socioeconomic status in different ways. It may be based on wealth, it may be based on income, it may be based on consumption, as long as it's something that is directly observed in that survey. Okay, so what that means is for each of these surveyed households, we have this measurement yi. So for household I, we have this value y that tells us our estimate of their true wealth based on surveys. Then we get data from the phone company about how this particular individual or household has used the mobile phone. And then there's this process that I won't talk about in too much detail unless you push me on it, of converting the raw phone data into what I'll call features or predictors, which are basically just like metrics on the last slide, like how many calls per day does this person make, or how many, we have information on social network structure and geography. So what's the characteristic travel distance of this individual, or what is the page rank of the social network of this individual? Anyways, a large number of characteristics and measurements that are derived from the phone data. So these are the X's. Think of X as a vector of hundreds or thousands of these measurements for each of the households. And then once we have the X's and the Y's, it's really a fairly standard supervised learning exercise where we say, okay, what we want is a fitted model that will allow us to predict wealth from the call detail records, in other words, the phone records from the X's. And again, there's a lot of details on what is the right representative training data that you need in order for this fitted model to be representative. But once you have this fitted model, then you can generate a predicted wealth score for every single mobile phone user in the country. Okay, and so what I'm showing you on the next slide Actually, this is results from Rwanda, is showing you roughly what it looks like. So here, each of these dots is one of the individuals that was surveyed. In this case, it was a phone survey, where we're showing you the predicted wealth based on phone data as generated from this machine learning model, and comparing it to the actual wealth as reported by the person when we spoke to them on the phone. And you can see that it's not a perfect correlation, but it's a relatively strong fit. And in this case, the phone-based machine learning model explains about half of the variation in wealth of this population of 900 Rwandans. I'll skip over this. And I think, look, the takeaway here, and this is something that over the last 7 years or so, we now have some perspective on, that across a bunch of different countries, across different points in time, we see that these phone-based wealth prediction models capture between 25 and 50% of the variation in socioeconomic status. Whether it's closer to 25 or 50 depends on a variety of factors, including the size of the sample, maybe things about the actual country, and in particular, what you're trying to predict. For instance, it's much easier to predict wealth, which is generally more stable and measured with less measurement error, than it is to measure consumption, which is a bit more volatile and is generally subject to a lot more measurement error. I see a question. So I'll just answer it very briefly. So the question is about how we construct the label for each household. So again, the idea here is we want to have a single value that tells us something about the relative wealth of that household relative to the other households that are surveyed. And so the problem is you can't just ask a household, how wealthy are you? Or if you ask them that, you shouldn't really trust the response you get. So instead, what is really standard in the development literature, and in development policy, is to ask households a variety of questions about living conditions. Things like, does your household have access to electricity? Does it have access to running water? Does it have access? Is the roof made out of metal or like thatched or other material? Right? A bunch of questions that tell us something of the correlates of wealth that are not truly about wealth itself. But then once you have a large number of these questions, say you have like 20 questions that you ask the household where you trust the answers, and they're all a bunch of things that are roughly correlated with wealth, then something like principal component analysis allows you to collapse that into a single dimension. So we take the first principal component of 20 or 30 asset-related questions. That's how you measure wealth. How you measure consumption is a little bit different. Maybe I won't go into the details unless people are interested a little bit later. Okay, so I've now introduced the basic.
Josh.
Yep.
While we're on this topic, I was wondering if I could ask a follow-up question. So on the mobile phone data, it must be a tremendous amount of data. And I was just wondering, like, and given the privacy implications, how did you do the computation on that data set? Was that sitting on the servers of the phone company? Did you anonymize it and bring it into your own server infrastructure? I'm just curious about that.
Yeah, I might defer a more extensive discussion of that question to the Q&A. I think the short answer is it depends. It depends on the goals of the exercise, the legislative and regulatory framework that you're working in. I'll say I've been involved in projects that run the spectrum from data being transferred from the mobile phone operator to a secure server at UC Berkeley, to a situation where we send someone in country to work with the mobile phone company, to something where we set up a system where we write code. The code is then sort of checked by an analyst at the phone company and run on the server, and the results are sent back to us. Again, it really just depends on the policy demands, in a variety of factors, but happy to discuss it more during the Q&A.
Mm-hmm.
Okay, so let me talk a little bit more now that I've laid out some of the technical machinery, at least at a high level, to how this is actually working on the ground in Togo. So a quick timeline. As noted, our goal is to improve the targeting of Novisi, this cash assistance program, in rural areas. So the first phase of the program, which we had nothing to do, was launched in late March and lasted through, I want to say, early July, and provided 3 months of support to the urban poor using this occupation-based targeting. What we've been involved in is the expansion of this program into rural areas. So what I'm going to show you today is results from an expansion that has already occurred in those first 100 poorest cantons. And it's going to be based on data that was collected in a phone survey that we conducted immediately prior to the expansion, as well as in the most recent nationally representative household survey that exists in Togo. I'll note briefly that this work is ongoing. So phase 2, an expansion to the second 100 poorest canton, so like ranked 101 through 200 in the poverty spectrum, is happening right now. And we've run another survey, well, a couple of surveys, one that is used to train the machine learning algorithms to target benefits in phase 2B, another survey that's being used to evaluate the impact of the transfers that were sent in phase 2A. And then we were planning to, we had actually trained all the enumerators and we're just about to send them into the field to conduct a large household survey in February and March of this year, but then there was a sort of a flare up in COVID cases, so we put those plans on hold. But eventually we're hoping to have another data set, a lot like this one, but just more recent, that will allow us to better evaluate some of the work that we've been doing. Okay, so again, in the rural expansion of Novici, this approach is being used to prioritize the poorest individuals in the poorest villages. And so what we did is we used that survey, that phone survey that was conducted in September of last year, immediately prior to the expansion of Novici, to train one of these machine learning models. And so this is what the actual trained model looks like. And again, I'm showing you the predicted consumption on the y-axis and the ground truth consumption. This is measured in the local currency on the x-axis. And what you can see is we have this correlation. It's not perfect, but just so you have a sense, what this implies is if we impose a targeting threshold of 403 FCFA, the local currency, that everyone below that predicted threshold is going to receive benefits, and everyone above it is not. And so the question we need to ask is about what are the inclusion and exclusion errors that occur because of this targeting mechanism. But intuitively, the goal of this exercise is to say, instead of, so this is showing you a few different versions of the wealth distribution or the consumption distribution in Togo. The blue line is the consumption distribution of the entire country. And this is based on nationally representative household survey data. The red distribution is showing you the distribution of wealth amongst people who live in those 100 poorest cantons. And our goal here is to really cut off the people in the the poorest of the poor and provide benefits to those people who are below this wealth threshold, which in practice is predicted consumption of less than $1.29 per day, which is very extreme poverty. Extreme poverty is defined as $1.90 a day, and this is substantially below that. Okay, so I think the top level takeaway, and then I'll have a little bit more nuanced results to follow in the slides that follow, is that relative to the other options that the Togolese government had available to them in September of 2020, this approach using satellite and phone data significantly reduces targeting errors, both errors of exclusion and errors of inclusion. Now, it's important to note here that in this slide, what I'm doing is I'm comparing this phone CDR machine learning approach to two other counterfactuals. One is an expansion of this occupation-based targeting, and another is a pure geographic targeting approach where instead of prioritizing the poorest people in the 100 poorest cantons, they would have done something where they gave everyone eligibility, but just in like the 5 poorest cantons, basically until they hit their budget constraint of providing relief to 60,000 people. So, these are not necessarily very competitive baselines, but they are the relevant counterfactual when analyzing the program in Togo. Okay, what this slide is showing you, and I apologize, it's a little bit dense. What we're doing is we're not just comparing our approach of this phone machine learning approach to the feasible alternatives that existed in Togo, but we're also comparing it to infeasible alternatives that might be relevant to other countries around the world. So in particular, it's very common in the administration of humanitarian social protection programs that the government would go out and collect national data for every single household on, like basically a poverty scorecard, where you go out and you ask every single household 10 questions that allow you to assess their relative living standards. And what you see here is that these traditional methods work about as well and occasionally much better than the phone and machine learning approach. Again, if the country has the resources and time to collect these, more traditional standards for targeting. So that's sort of like the crux of it. I want to be conscious of the time and wrap up in the next few minutes. So I'll just show I'll give you a sense of some of the other questions we're asking and have results for. Again, in case people want to return to this during the Q&A. I think it's really important and interesting to ask, in addition to these numbers of like improvements in accuracy and area under the curve and precision recall, how does this translate into social welfare? Now, of course, to answer this question requires that we come up with a formal definition of welfare. But this is something that economists have been doing for decades. We can evaluate this, and while I won't sort of go through the results in detail, using relatively standard assumptions about social welfare functions, we can assess not just what the relative performance is of these different targeting approaches, but what the optimal value is of a transfer, right? So the government had decided on $15 a month for women, $13 a month for men, using their own logic, but we can say from a utilitarian maximization perspective, what would the optimal transfer be? Because again, the larger the transfer, the fewer households you help. The smaller the transfer, the more households you help. And so, this interacts very interestingly with the accuracy of the targeting mechanism. Another really important question that I'm sure many of you are wondering about is potential sources of exclusion from this particular phone-based targeting approach. On this slide, I list some of the key sources of exclusion that we're aware of and studying, and I'll just list them briefly. And on the right, you can see our best estimates of to what extent each factor is causing exclusion. So first of all, you have to be registered to vote, right? In that voter registry. So again, I didn't talk about this in too much detail, but to receive benefits from Novisi, you pick up your phone, you dial a short code, and you enter your voter ID. And the voter ID is used both as a unique identifier to make sure that no person receives more than one set of benefits, and as a way to determine your home location, because eligibility is in part based on home location. So not everyone is registered to vote, and so we can see the exclusion errors that occur over here. You have to have access to a phone, and you have to have a SIM card. You have to learn about the program, decide that you want to self-target and register, and then you also have to succeed in registering. And we see that for a variety of reasons, there are not perfect success rates in registration. So there are these four, what I'll call like hard environmental constraints, even before you get to this issue of the errors that occur, the targeting errors that occur from our particular machine learning algorithm. Another key consideration, and this is something that I think we're all well aware of now as a society, is that there are both overt and very subtle biases that can creep into, or maybe creep in as being too generous, that can be baked into machine learning based decision systems. And this is a very high stakes decision system. And so we want to see whether or not there are obvious or subtle sources of bias in the algorithm. Again, this is something we can potentially return to in the Q&A, but some of the work that we've done suggests that, at least for salient, they're not technically legally protected attributes, but the sort of attributes that you would want to see balance in fairness against. We see, for instance, with gender, ethnicity, religion, and age, there aren't systematic mispredictions for one particular subgroup. I can talk again more about this later. So just to wrap up, I think I have two more slides. I think hopefully at this point in the talk, I've convinced you that this approach is accurate, at least accurate relative to the other options available to the government. And it's also very fast and very cheap relative to traditional options for distributing aid. But I haven't really talked about many of the concerns that arise. I guess Andrey alluded to the first one on this list. This is a list of some of the things that I'm happy to discuss that we've thought a lot about. And I think what has been one very interesting aspect of this project is that understanding and designing systems that are very conscientious about these considerations actually took more time than like the basic technical aspects of training the machine learning algorithm. So I'll just briefly mention some of them here. A big concern obviously is setting up the system in a way that maximizes data privacy, right? Like human rights doctrine emphasizes that any sort of encroachments on privacy need to be necessary and proportionate. I think we can all agree that we want to enable effective humanitarian response, but of course, it's important to consider what the cost is to privacy, among other things. And related to this, we want to make sure that any encroachments on privacy are temporary and don't enable sort of future misuse. We want to make sure we have a systematic way for thinking about getting benefits to people without phones. So one small thing we did there was make eligibility based on having a SIM card, not a phone, because getting a SIM card is relatively cheap. Getting a phone is relatively expensive. I talked a little bit about algorithmic biases. We can talk more about it. Also really important is how to think about designing this system, which is really a system intended for crisis response, into long-term equilibrium systems for social protection that are not really so immediate and responsive. Okay, I have an article from a couple years ago where I talk about some of these issues in more general terms, but in more detail if people are interested. And then finally, I'll just mention that while I've given a very high-level overview, I just want to make the point that for those in the audience that are more on the data science, computer science end of things, there are lots of really rich and unanswered technical questions that come up in this line of work. I think I'll mention a few areas that we're working on, but by all means, there's need for more smart people to work on these questions. One is about privacy and the question about, can we design a system like this that provides provable guarantees for individual privacy? A second has to do with like online learning, active learning, and adaptive sampling. Right? I've talked a lot about how important it is to have ground truth data to train these models. Well, what is the optimal way to sample that ground truth data? Because that ground truth data is very costly to collect, and the costs are heterogeneous. It's more expensive to collect data from some populations than from others. Can we think about this as an optimization problem in order to most efficiently use limited resources available for data collection? Another question that comes up is the one of strategic classification, which is that when you're providing benefits to people using an algorithm that is based on phone data, well, that introduces very strong incentives for people to change the way they use their phones strategically, to manipulate or game the system. So how can we design programs like this that are robust to such manipulation? And then finally, another area that I think is very interesting, I previewed a little bit, is to think about designing systems that maximize some notion of social welfare or social impact, rather than the traditional optimization criteria used for machine learning algorithms, like root mean squared error or maximum likelihood or something like that. This, I think there's been some interesting papers coming out in the last few years, but is a very wide open area for future work. Okay, so that's it. I just want to like wrap up by saying, I think hopefully the top level takeaway I want you to get from this is that in this particular instance of humanitarian aid targeting, machine learning has a lot to offer. And I think it's representative of this area at the intersection of computer science and poverty or development research. But while there's immense potential, there's also a lot of potential pitfalls that require careful attention. So I'll conclude by just also briefly pointing to some of the other members of the research team from our COVID era group meeting that have been working on this project. I want to really single out Emily Aiken and Suzanne Bellew, who are two PhD students. Emily has really been the driving force behind a lot of the work that we've been doing that I presented today in Togo, and Suzanne is driving some of the work on the impact evaluation in Togo. Guanghua Chi is not in this picture, but he was the driving force behind building those micro estimates of poverty And then there's a whole cast of characters that have been really instrumental in getting this project from like a bunch of research papers that had been published over the last few years into something that's actually being used to help design policy both in Togo and Nigeria. So with that, I see there's a couple questions, but I'll open it up. I guess Andrey, are you going to moderate? Can I hand it back to you? But thank you all for your attention.
I can moderate. So we have one question currently, but I really encourage everyone else in the audience to ask questions as well. In the econ style, we like to ask a lot of questions. Sid George has a question. The first part of it is, how good is mobile phone data predicting changes in income, consumption, and wealth over time? And I just like to like follow up on that, which is that you might actually expect that during COVID, the mapping between some of these measures, like the road quality, becomes a lot weaker in terms of correlation with the consumption measures. So
yeah, thanks. Those are all really good questions. I will pull up one slide that, well, let me give you the top level answer to the first question, Sid, is not very well. So predicting changes over time is much, much harder than predicting levels. And intuitively, you see this already when I said that predicting wealth is a lot easier than predicting consumption. So we have, quantitative evidence on this using panel surveys. What I was going to show you was this slide here, where we're looking at this exact question in Togo, where it's not terrible, but what I'm focused on this table here, because we have a few different surveys in Togo right now, we can say, okay, how well does the model trained on nationally representative household survey data collected in 2018 work in predicting wealth in 2020? And so what you see is a general decline in predictive performance as you increase that gap between the training data and the sort of current data. And so I think this is a really open, interesting area for future research, is to build out predictive algorithms that can accurately predict changes over time, because that is one of the most interesting and policy relevant outcomes. And Andrey, you were alluding to this too. I'll also say that this is not unique to phone data. There's been recent work. Chris Yeh, Marshall Burke, and co-authors at Stanford have a paper that came out last year in Nature Communications about the extent to which satellite imagery can predict changes in wealth over time at a household level. And the results are very mixed. I think you should ask them, but I think the takeaway there is that's very hard too. And that's over multi-year timeframes. I think intuitively there's hope that with phone data, you could predict relatively short-term changes in welfare. But so far there hasn't been a lot of evidence that it works. And so again, people have only been working on this for the last couple of years. It's wide open for research. And let me just sort of briefly touch on Andrey's follow-up, which is how would a model trained pre-COVID work in the post-COVID era? I think the short answer is I don't think we should assume that it would. And that's why we worked really hard in Togo to collect that training data immediately prior to the expansion of the program. So, we had this existing survey data that was collected in 2018, 2019. We also conducted a phone survey in June 2020. But immediately prior to the expansion of the survey in October, we conducted a phone survey in September, specifically for this reason, which is that we wanted our best estimates of people's consumption in circa September of 2020, not circa June or circa 2018, 2019. Now, I think this is important because in a lot of situations, you won't have that opportunity to go out and collect ground truth data on a dime. We had great partners in Togo, in the government, and the World Bank, and Give Directly that made this possible. But I think it's important. I'm sort of harping on this because I think there's a temptation to say, oh, let's just use whatever survey data is available and match it with the phone data, and then we can deploy this. I don't think that's the case. I think you need to think really carefully about how to collect the right training data for the exact purpose, the exact policy application that you have in mind.
Thank you. Sid also has a second question, which is, how important is it to have the CDR rather than mobile data / app usage, e.g. of the kind that providers like Unicast offer?
Yeah, that's a really great question. So, one other, let me stop sharing my screen. One other thing that's going on in a lot of low and middle income countries. Sorry, are you seeing my screen? Oh, I never did. Sorry, I had a slide to your first question, Sid, but you can't see it. Sorry. Is a lot of private companies are offering microloans via, it's called digital credit, using mobile money systems to provide short-term, high-interest loans to people where they're using mobile phone data and machine learning algorithms trained on that data to determine a credit score, which is basically exactly what we're doing, but instead of predicting wealth or consumption, they're predicting whether or not you repay the loan. A collaborator of mine, Dan Bjorkergren at Brown, has done a lot of work on this exact question. And I think the point there, coming back to your question, Sid, is that they're using the app-based data, right? Data that's collected through a smartphone app rather than the metadata collected by an operator. I think an advantage of the smartphone approach is the data is actually much richer. It's a superset of the information that you can see from the data collected by the operator. Two disadvantages are that the privacy considerations are perhaps greater, but also particularly in a place like Togo, smartphone penetration is much, much lower than standard cell phone, like feature phone penetration. So estimates in Togo are that something like 90% household penetration of any phone, but something like, it's harder to get data, but closer to 20% penetration of smartphones. So there's an issue of representativity there.
All right, thanks for that answer, Josh, and also just thanks for the great presentation. I just want to finish up by encouraging the attendees to attend a panel that's going to happen on Monday at 11 o'clock, and I'll hand it off to Eric for final comments. You're muted.
Thank you. This is a fantastic presentation. We really enjoyed it. I'm looking forward to chatting with you and hearing more about the panel, particularly digging in, I think, in some of the questions regarding privacy, bias and whatnot, which I know is definitely an interest of a lot of folks here in their basic research at BU. Andrey, thank you for hosting, and thank you for bringing Josh to our speaker cluster here. As Andrey said, we have our panel on Monday, so if you can, please join us. We'll bring all our speakers back together. If you want to catch parts of this video again, you can see it on our YouTube channel. And again, I want to just thank the junior faculty fellows in general for organizing, and wish you all a good weekend. So thank you.
Great, thank you all.